Alright, this is a continuation of the factoring worksheet. We're on number 15. Alright, we're going to treat this as a sum of two cubes. Negative 27. Cube root of that is negative 3. And cube root of x cubed is x. Plus cube root of 125 is 5. Square the first term. Change the sign. It'll be minus. This is the weird part. The negative 3x is negative, so it's negative 3x times 5 is negative 15. So it's a minus a negative 15x. So that becomes a plus 15x. Plus 25. Okay. The trinomial here is generally unfactorable. Turns out I was wrong, especially if, I'm wrong when that's not a 2. I encountered one where you split up it was an x to the 6th, where the exponent was not a 3, but it was still a perfect cube, and it turns out this was factorable. But I have no techniques to show you to factor a trinomial into two other trinomials. So, if you know how to do it, let us know. Alright. But this does not factor. Okay. Alright, here we go. So this one is a classic trinomial. This is the real trinomial. This is the one you practice in Algebra 1. As if they were fake trinomials. Sorry. Okay. Lizzie method or trial and error. I'll do trial and error on this one, because there are very few choices for 3x squared. 3x and x. That's the only choice. Now I want to get 8 in the middle. I'm just going to guess 2 and 2 for the 4. 2x plus 6x makes 8x. Easy. 19. Oh, this is the one. This is similar to the one I was talking about. Okay. This is a difference of two squares. But because we don't have a technique to factor a trinomial into two other trinomials, I recommend that you treat this as a difference of two cubes. Okay? That way you can get a bunch of factors out of this. Alright. So when I treat this as a difference of two cubes, what do I get? It's 4x squared minus 1. Square that. Square this, rather. And I get... Scratch that. Difference is two squares. 8x cubed minus 1. 8x cubed plus 1. Treat it as a difference of two squares. Then split it up into the difference and sum of two cubes. Ugh. So that becomes 2x minus 1. 4x squared plus 2x plus 1. That's 2x plus 1. I'm factoring this now. So it's 4x squared minus 2x plus 1. Alright, sorry about the confusion. I was starting to look ahead and I realized I was wrong. When I look at this problem, I'm going to split it up into difference of two squares first. And then I realized then that this becomes a difference of two cubes, which I split up. And the sum of two cubes and split up that way. Okay, I'm sorry if that was confusing. 21. This one's a sum of two cubes. didn't explain anything that time. But we've done this several times. Well, there's the answer. Let's move on. Sorry. Maybe the second video is just awful. Anyway, 23. Okay, here we go. Quadrinomial. Let's split it up into groups. Factor out a 4x squared. That'll give me 4x minus 5. Oops. Alright. Remember, if there is a negative in this term, the third term, I always take it out. So it's like negative 1. That changes signs. That makes it 4x minus 5. There we go, 4x minus 4. Take out the 4x minus 5. And I get 4x squared minus 1 left over. 4x squared minus 1 is a difference of two squares. So it's 2x minus 1, 2x plus 1. Moving on. Number 25. Oh, joy. Okay, it's quadrinomial again. It's very similar to 23. It's our group. Now, what are the common factors of that one? Well, something next to the fourth. 9? Let's try that. It'll be 9x to the fourth. 36 divided by 9 is 4, leaving me x squared plus 3. Right? 27 divided by 9 is 3. X to the fourth, I've taken out. Minus, I'm taking out a minus something. What goes into both of those? 8. How about 8? Okay. 8 comes out, leaving me. 8's not big enough. Let's take out a 16. And take out a 16. 16 times 4 is 64. Since I took out a minus, that minus turns into a plus. 48 divided by 16 is 3. Woo. Okay. I'm going to take out a 4x squared plus 3. Leaving me 9x to the fourth minus 16. That's a difference of two squares. So it's 3x squared minus 4. 3x squared plus 4. That one kind of looks like the difference of two squares, but the 3 is not a perfect square. So, we're done. That's 25. These are getting more complicated, aren't they? Welcome to Algebra 2 Honors. 27. Okay. This one's not that complicated. We can try this Lizzie method, or we can do a trial and error. Let's do Lizzie method. This is what I do. In my head, I just try to see if I could do trial and error in my head really quickly. If I had 5 and 5 here, one of them had a 3. 5 times 3 is 15. Okay, I'm going back to trial and error. Oops, sorry. Plus, that means they have to have the same sign. This plus means they have to have the same sign. And the middle sign tells me they're going to be negative. That's it. In case you couldn't follow that, which I completely understand because I didn't explain much, I will do Lizzie method as well. So let's see. Lizzie method says 25 times 3 is 75. What are the factors of 75 that combine to make negative 20? How about 15 and 5? 15 times 5 is 75. Negative 15 plus negative 5 is negative 20. So, Lizzie method says this. I say x minus 15 over 25. X minus 5 over 25. Simplify or reduce your fractions. 5 goes into that. 3 over 5. That becomes 1/5. Move your denominators up. Yeah. So, we get the same answer either way. It looks like the Lizzie method is more work, but I don't know. Maybe it is. Maybe it isn't. If you can't think of it, Lizzie method is better. All right. 29. Okay. Another trinomial. Ooh. Do we do Lizzie method on this one? Well, I can't think of anything. Well, what would it be? 5x, 5 and 3. 9 and 4. I have to subtract. Ugh. Let's go Lizzie method. What's 15 times 36? 180. 36. 540. Uh-oh. This is going to kill the rest of my video because I'm going to spend 5 minutes trying to figure out how to factor that out. Okay, when I get stuck like that, I punt. What I do is I break the 36 and 15 down. So this is, I look at combinations of these things. 9, 4, 3, 5. So let's say 12. Okay, what am I saying? Instead of trying to factor 540, I go back and factor those two. And then I look at combinations of those factors. So like 12 and 45. Well, that didn't work. Remember, my goal is to get 7. And because it's a negative 36, they want to have to subtract to make 7. So that's not good enough. So maybe these numbers are too big. That's what I'm thinking. Oh, they're not close enough. Let's see. How about 3 and 12? 3 and 12. 12 times 3 is 36. 3 times 5 is 15. That's still too far. Let's see what else is there. Oh, maybe it's 15 and 1. Ooh, 15 and 1 sounds good. So let's try 3, 12, 15, 1. Multiply those together, I get 3. Whoa, let's go the other way. No, nothing's going to work. 15 and 3 is still too big. That'd be 45. 12 and 1 is 12. Oh, or maybe I'm looking at the wrong thing. Maybe we'll go this way. How about 27 and 20? Ah, I bet you guys saw that, didn't you? Alright, so we can look at 27 and 20. Alright, so we want positive 27, negative 20. So we say x squared positive 27 over 15. X squared minus 20 over 15. Okay, sorry if you didn't catch that. Remember, I listed the factors of 36 to be 9 and 4. Just randomly chose. I mean, there are other factors. 15 was 3 and 5. What I'm trying to do is really factor 540. And I did that by breaking up these two. Then I'm looking for combinations of these or other ones. These are my other experiments. To combine to make positive 7. Well, I got stuck in a trap, going only sideways, looking at the factors this way. And then when I changed my tactic and looked at the factors this way, I finally saw it. 9 times 3 is 27. 4 times 5 is 20. 27 minus 20 is my positive 7. Okay? Alright, so that's how I got these numbers. Now I reduce. Alright, 3 goes into both top and bottom. 9/5. 5 goes in the top and bottom. 4/3. Move 5x squared plus 9. 3x squared minus 4. That's a difference, but 3 is not a perfect square. So, that's it. Alright, that's it. Bye-bye.